Hi everybody. I really hope that you watched the first video I posted because I found that one and he was basically saying and doing every single thing that I wanted to do. But he had a different program than I had and I thought it looked really nice and he explained everything very, very clearly. So please go watch that. That covered graphing sine, cosine, and tangent of theta from the unit circle. And what I'm going to be covering right here, I'm just going to do one example with you, but we're going to be covering shifting, stretching, and transforming sine and cosine functions. So this is 7.6, and what I want to show you guys first is just the general formula. So it equals a, and then it could be sine or cosine. I'm just going to write down sine for this right now. So sine and then b, and then in parentheses we would have theta minus h, and then on the outside we would have plus k. So I'm obviously going to be telling you what each of those things are. So what we get with a, the absolute value of a, that would be the amplitude. So if you remember, that is from the midline, how high or how low we have to go from the midline to get to the maximum and the minimum. For b, what that is, you would take 2 pi over b, and that actually gives you the period. So if you remember in the video that you just saw, hopefully the period is how long it takes to get through one complete cycle. So that is how you would find the period. When you are at h, and I'm actually going to say negative h, that's going to be what's called a phase shift. And basically, hopefully you remember this when we did transforming functions, that is going to essentially be the horizontal shift. And k, I hope after h you recognize k. K is just the vertical shift. And the kind of cool thing as well is that y equals k is the midline. Okay, so this is how you would deal with a sine or a cosine function. And I'll actually just put a little asterisk there and also say or cosine, because I want you guys to know either of them, this is what you would do. So you have to look at the value of a, the value of b, h, and k, and if there are values there, then you'd have to either change the amplitude, period, shift it horizontally or vertically. So we're going to get into one example with this. Okay, for this example, we're going to need to graph sine of 2 theta minus pi over 3 minus 3 halves. Right below, I have just put the regular graph of sine theta, which should look familiar to you guys. I'm counting by degrees along the bottom, and each line is 15-degree increments. And then, as you saw from the video, it starts at 0, 0, maximum of 1, minimum of negative 1, and if you look, at 360 degrees is when it gets back to 0 again. So that's one cycle. So what I'm going to do is I'm going to highlight all the things in this that I'm going to need to be graphing. So I have right here sine of 2. That is going to be helping us find our period. If you remember, 2 pi over that will be the period. I also have this value right here, minus pi over 3. That is going to be my horizontal phase shift. And then I have the minus 3 halves, and that is going to be my vertical shifting. So first let's figure out the period. So I need to do 2 pi over b, and that will give me the period. So that is going to be a 2 pi, and b is 2. Cancels out. That means my period is going to be shifted to just pi. So basically this whole graph, instead of going all the way to 360, remember pi is 180, so I'll just put that there as well. Instead of going all the way to 360 to complete one cycle, it's going to be smushed in and it's going to complete the cycle by 180. Next thing, I am going to find the phase shift. It is a minus pi over 3, and I am again going to convert that into degrees. That is 60 degrees, so pi over 3 is 60 degrees, and it's a negative 60 degrees. So that means I am going to be going to the right 60 degrees. So everything is going to be shifted to the right 60 degrees, which is going to be 4 increments on my graph because we're counting by 15s. The last thing is going to be my vertical shift, and that is with this -3/2. So I'm just going to make that. That means I'm going to be going down 1.5. So instead of starting at 0, it would be down to 1.5. So to kind of start this off, what I'm going to do is I'm going to deal with my period changing. So instead of the period being 360 degrees, it's going to be 180. So to do that, I'm going to, again, still be starting at 0, but then everything is going to be squished down. So it's going to need to, at 180, be back to its cycle there. And then I'm just going to shrink everything down, basically. So instead of this being the maximum at 90 degrees, it's going to be the maximum at half of that, which is 45 degrees, which would be right here. Hold on. Right here. And then instead of crossing back at the x-axis, at 180 degrees, it's going to be half of that. So that would be at 90 degrees, which would be right here. Instead of reaching the minimum all the way at 270, it would reach that right about here. And then that is going to be kind of what my little sine function is going to look like. Right, it's going to be small like that, and then it would be repeating itself, which we can do. But so that's how small it's going to be. And then now I'm going to need to take this, shift it to the right, and then shift it down 1.5. So shifting it to the right 60 degrees. We'll do this one in green because we're going to the right in green. So everything needs to get shifted 60 degrees, which is 4 lines over, right? Because each one of these represents 15 degrees. So if I'm going to go 60, that means 4 of them. So instead of my point being at 0 right here, it's going to go 1, 2, 3, 4 right here. This maximum is going to go over 1, 2, 3, 4, and it'll be right here. Same with all the points, 1, 2, 3, 4. Down the minimum, 1, 2, 3, 4. And back up to 0, but 1, 2, 3, 4. Okay. So this is changing the period, and it is shifting it right 60 degrees. And then now what I'm going to need to is move it down 1.5. So if you look, 1.5, instead of being at 0, 1.5 is in between -1 and -2. So it's going to shift down to here for that point. This is going to shift down 1 and then a half. This is going to shift down 1 and then a half. This will also shift down 1 and a half, and the last one shifts 1 and a half. Okay, and then try to keep it as smooth as you can, and then that is just going to be repeating itself. So then in 4, it'll go back up to right here, and so on and so forth. And you can just keep mirroring it and going through. So this purple one, this should be what the final graph is. Okay, that is us shrinking the period down, shifting it 60 degrees to the right, and then down 1.5. There's a lot of steps in it, and as you can see when I'm doing it, I graph multiple lines for every single step. I never try to do it just as one thing. I just find that it's easier to do it bit by bit. And actually, because I did that one in red, I kind of wish I had done it in blue, so it'd be lined up with, the period change right there. So I'm just going to highlight that in blue. Hopefully that makes it a bit more clear if you're kind of wondering about that. You can always check your answer on Desmos, and actually I do have that. I put it on Desmos so I could see. Please be aware though that when you guys are doing these, I'm going to need to see all your work. So please write it out like how I just did, where you're either color coding or just labeling out everything, any amplitude changes, period changes, horizontal phase shifts, and vertical shifts. Let me show you guys the Desmos answer. So here it is on Desmos, and the part that we graphed was just this little part right here, and then we brought it back up. So obviously on Desmos, it does the whole thing. It does it very smooth and nice, but it is a really great way to check your answer from the original to what you had. Again, please make sure that you guys show all of your work because I'm going to need to see everything from you so that I know that you didn't just type it into Desmos. Because then obviously you're not really learning anything. But it is a really great way to check it out. So please do that. Bookwork's just going to be, I think, 1 today, and then classwork will be a couple because they do take a while. Please ask if you have any questions. Again, take it step by step. Never try to do it all at once. And for me personally, I like changing it into degrees. If you like radians, you can leave it as radians. You can do it as degrees. Doesn't really matter to me, but I think degrees are easier to work with for this kind of graphing. Like in the video where the guy used decimals instead of radicals. So go ahead, try these out. Good luck. Take your time. Check them on Desmos. All right. Have a good week, you guys.